Okay, when you test or do proof of concepts, a lot of times you just want something very small, but it needs to kind of represent a larger set of data, or a very large set of data. But you don't want to deal with large sets of data are bulky and they are slow to respond, and it makes your development cycle longer. So you'd like to take the exact same structure and data, but in a much smaller sample of it, so that you can develop and test and iterate through your tests quickly. And then once you get your code working the way you want, then you can go ahead and escalate that code up to a larger database testing system, and make sure then that it also scales properly for performance reasons. Okay, so that's what we're trying to do here. So I have a database that's very large and a table that 517 million rows. And really, to do a lot of stuff with that kind of row set, it's much slower. So I want about 600,000 rows. Okay, that I can work with and get tests done pretty darn quick. So remember, I want to have the exact same database and the exact same table structures and everything else exactly the same as a super large database. But I don't want that 517 million rows. I only want 600,000, which decreases the size of that database immensely. Okay, so I have to figure out how do I get there without messing up any of the structures, right? So the first thought is, okay, I take the database and I take the 517 rows and I delete out everything to get down to 600,000. Well, this 517 million rows, you do that, and it also has index views on it already. It's going to take forever to get that thing to decrease to that space. Okay, you probably run out of resources. You'd have to write special code, because it's would probably take up the transaction log. All sorts of messy stuff with that. Okay, so I came up with, and also just to restore the database. Okay, I could also restore the database to a whole new database called small, right? And then again, try to get rid of those rows, or ETL the big rows to it. There's several ways of going about this. Many of them wrong, and many of them will take a really long time. So I know just to restore that database takes at least an hour and a half. So what I decided to do was go ahead and there's several steps to this, what I'm going to do. But what it incorporates is a database snapshot technology, which is an enterprise edition feature. But it's a really great feature for many different scenarios, this scenario being one of them. So I'm going to go through the steps on, we make a snapshot of the database, which takes, the database is like 64 gigabytes. I know database snapshot will be faster. So basically what you do, and I'll go through all these steps, but in general, we're going to create a snapshot. You can kind of look at it sorta as a backup. Okay, except for there's nothing in it hardly, and it gives you a point in time. And then I'm going to go through all my processes, kill that big table, make it really small, and put 600,000 rows on it. I know all my structures are the same, all the indexes are going to be the same, everything's going to be exactly the same. And then I'm going to, except for instead of being 64 gigabytes, it's going to be extremely small. It probably won't even be it'll probably be a few, 50 megabytes or 20 megabytes. I'm not sure, but it's going to be tiny compared to that size. Okay, less than 1%, way less than that even. Okay, so basically that's what I really want to do. And then after I finish doing all that stuff, I want to do a quick restore of that database snapshot instead of full restore of the whole database. And I think we're going to see time-wise that it's much quicker than doing this full database restore and all this other stuff that we could do. So that's what the whole point of this lesson is. And I'm just emphasizing this snapshot, this database snapshot technology, because it's really cool and you can use it for all sorts of good stuff. I just want to introduce you to it. There's so much more about it. I'm just going to show you just the top of the iceberg with this thing. Okay, so we're going to go ahead and move forward. Overview. The problem: database you want to change into a new proof of concept template database takes too long to restore. The solution: perform a database snapshot that you can restore after all processes to the new proof of concept template database are completed. Okay, I'm going to start with a demo, and this is the demo, and there's 10 steps to this demo. I'm going to have it in a document that you can download from, based on the hyperlink you'll see in the description area of this YouTube video. First of all, I want to go ahead and see what what we have in the current database. The database we're looking at is POC, Proof of Concept Template, DW Large. This is a 64 gigabyte database with the big table, which is 517 million rows. I want you to take notice up here, though, that there's an area up here called Database Snapshots, and right now we don't have any snapshots in our server. We could have many snapshots. We could have several snapshots for the same database, for that matter. I could have one for every end of month process. But there's a lot of details with snapshots, and I encourage you to read up and get all the details about it before using database snapshot. Okay, so we're going to go right back over to I've discussed our scenario and what I'm trying to do. So we're going to just look at what's in that big table just from the get-go here so we can remember this later. So I run this query here, and I get the results, and the results are down here. Okay, so we see we have the 517 million, and I had discussed the problems with that size table. Now here is where I do the actual snapshot. So you see create database, and I put down the name of the database plus the word snapshot and plus the time I created it, which is 2017 April 19th at 10:25. Now it's 10:27. And then we give it the name and where we want it stored. So it's going to be stored out on G snapshots Z with the same name. And here's the magic here where you say as snapshot. So I'm backing up the database name here, or really the file that it's saved under, or the logical name that it's saved under in the file properties, and which we can look at right now. We can go here and say properties, and I go to files. And there it is there. So you see that's with that underscore data at the end. So in this case, I don't have to back up the log because I don't have a transaction log. I keep it in simple mode for recovery models. So I'm only backing up the MDF as a snapshot. So again, here is a snapshot. Now you think, okay, well, we're going to create a database, a snapshot. How long is this going to take? Well, let's see. So I execute. And it's done. So it took 1 second. Okay, so that's 1 second to create the snapshot, because it basically takes. It's hard to explain. You can look at the videos and stuff online on snapshots, but it takes a starting position which has really nothing in it. So I mean, if we go to G snapshots here. And I go out and look at the size of that file. Here's the file, okay? So if I right-click on that file name, that's what was just created, I look under properties, it says here, size 61 gigs, or 65 gigs if you look at it from this perspective. But look at what size on disk is. It's 128K. That's really how big it is. So what it does with this snapshot business is that whenever something from the time you make that snapshot going forward occurs, then it updates the snapshot. So basically it's just a baseline. It's not a real backup. So don't treat it like a real backup. You got to have your backups. But a snapshot gives you a point in time, and then any changes after that are recorded into the snapshot. Okay, and then when you want to revert back to where the snapshot was, all it has to do is revert those changes back, not the changes that were made since the snapshot was created, nothing before that. Okay, so again, it's the same as a backup, but it acts in our scenario, will act the same way. But you really need to understand it. So don't go getting rid of your backups, okay? Because this is not going to be suffice as a backup. Okay. So that's step one. We've completed step one. We're going to go to step two. In step two, we're going to count the rows in the table, both on the database and the snapshot, okay? So here's a database in the big table, which is Fact Online Sales. And here's the same database with the snapshot. So I can query against the snapshot. I can come in here and go to the snapshot, right? And refresh and see the snapshot here. And it looks exactly like the snapshot I have, or like the actual database it's emulating. Okay, it has exactly the same tables, everything's exactly the same, but really it's just a pointer over to the main database, more or less. So when I run a count on both of them, the counts are going to be for that table, as you see here, they're both the same, right? The same counts. Okay. Now I go to step three. And here I'm going to go ahead and copy 600,000 random records from that big table. Remember I said that's how many I want. I'm going to stick them into a temp table right here. All right. So what I do, I'm going to prove this how this works. This particular, there's two ways to do this. You can use something called table sample clause in a select, but that's only good for 2008 and onward. And it's super fast actually, and it's really pretty good. I mean, it's not as random as this methodology here, but because it's at the page level, this actually goes down to the row level for the randomness. So anyways, right here, I'm just going to do a count before I push it into a temp table. I just want to see how many, how close it gets to that 600,000, because basically I take the total number of rows that's in the source table, 517 million. Then I divide it by the number of rows I want out of it, and it gives me this number I can use as a denominator. And then 1 over 862 basically is like 0.0012, and that's when you take that 0.0012 times the 517,000, you get 600,000. Okay, some algebra there. So as long as I just make that modulo down here equal to 1, basically I'm doing a random GUID, and I'm taking a binary checksum of that GUID and a cast to integer and an absolute value of that in case it's negative, and I divide it by 862, and whatever anytime the remainder is 1, then that's going to be part of my result set. Okay, you can review how that works on your own, but that's the formula. It's let me go ahead and do that select now. So this is just going to give me the count, and what I'm expecting is somewhere close to 600,000. Give or take a small percentage. Okay, I don't expect it to be exactly 600,000, but I'm just getting an idea of what the count is going to be. Okay, so we came back with the answer there, and it's, like I said, 600,911, so it's pretty close, and that's all I really care about, is it being close. It doesn't have to be exact. I can always delete out 911 rows if I'd like. Okay, so actually I'm going to go ahead now and actually insert that from that table, all the columns and values, and push it in there using this statement here. Okay, so it's the same statement except for I have the into temporary random sample table. Okay, that completed, and that took 2 minutes and 36 seconds. 2:36. Okay, so we got the 600. That time we got 601,273. So you see your randomness is picking out random sets of rows even. It's not even exactly the same number. So, okay, so we're going to go to step number 4. And now we're going to truncate the fact online sales. That means we're going to truncate that 517 million row table. Okay. Why? Because I want to take these 600,000 rows and push them into that table, and only those. So first I want to get rid of the 517 million rows. Okay. But let's just double check to make sure before I do that. Okay, so before I truncate that table, I just kind of want to make sure in my temp table, random sample table, that it has its, really has the data in there. So I'm going to execute a similar query that I did with the big table. And as you see here, we get 2,790,000, 173,300, 237,000, and a grand total of 601,000. So that looks good, and I've seen this before. That's the data's right. Okay, those rows are fine. In fact, let me just do that too to make so you can see that the values did come in there. Just look at the 1,000 rows and see. There's our online sales key. There's our dates, and look how nice and random they're fairly random there. And as we fly through here, it isn't like we're getting chunks of data that are all the same. And then it fills in all the rows, right? So that's all on temporary in the temp DB right now, and I want to get those back in here. And you look at this is the identity column. As you see, it is an incremental. One after the other here. It's very random. Okay, so that's cool. So we got that. We got what we wanted there. We have that the 601,000 rows I want to put in there. Now I'm going to go ahead and hatchet that fact online sales table. I'm going to truncate it. Now, why can I truncate that table? Because I have the snapshot, the database snapshot that I can go back to later. So it isn't like I'm going to wipe these out and I'm in trouble. I know I can go back to it pretty quick later, relatively quick. Okay, so I'm going to truncate it now, and it's done, right? So now I come back to fact online sales here, and I do that the one I did originally, which had 517 million rows. I do that, and now there's nothing. Okay, so what do I want to do now? I love this thing because I still have okay, so I have the roll up here, and it equaled nothing. So what I'm going to do now, I want to insert, because I like this. I have that structure. I don't have to worry about anything with the structure part. Okay, I'm moving on to step 5, which is where I insert the 600,000 plus rows back into fact online sales. That way I keep the same structure as fact online sales. But I do have an identity column on the fact online sales that I don't want to reinsert these rows and get new online sales keys. I want exactly the same online sales keys that I pushed out of there in case they're combined with something else for some reason or other. So I want to push those back in. So what I have to do is set identity insert on for that table prior to executing the insert. Okay, so I got an error there. Let me just replace that. Okay. All right, so I set the identity insert on, which means it's going to it's not going to force the identity column on the insert. It's going to take the column I give it and use that. Okay, So I'm going to execute this insert. And again, the insert here was insert into the fact online sales, which is empty now. And I'm selecting from that temporary table, which has $601,000 rows in it. And when that completes, then my fact online sales will have 601,000 rows in it. Okay, which is exactly the goal of what I'm trying to do here. Okay, I'm trying to make that database, that large database, into a small database for small time testing. Okay, that 601,000 rows is completed. I need to turn my identity insert off. Okay, again, I have my error there. Okay, so now if I go back up to that query to look at fact online sales this time, right, not the temp, this should be exactly the same as what the temp table looks like. And it comes back very quickly, 601,000. Beautiful. So now this database looks exactly the way I want it to. It's exactly the same as a big database, except for I have less rows in that gigantic table. Okay? I'm just going to show you that the random table and the fact online sales now are exactly the same. They have the same, when I run the test query, as you see, they both come out the same. Okay? Okay, now I'm going to go on to step 7. Now, step 7 is what? I have the database exactly what I want with it. It's a small database. So what I'm going to do now, which is critical, is I'm going to rename. I'm going to go ahead and save this still under the name large. I'm not going to go through anything special here, but I'm going to do a backup of it. And on the backup, instead of using the normal large backup, I'm going to say, remove that. I'm going to remove that and add a new one. And on that one, right, they have ZPO as large. But on this one, I want to keep the word large there for now, because this is only temporary. I want to type in small. Or let's say for small POC template. All right, I'm pretty verbose. Okay, so that will be my backup there. All right, let's make sure do an overwriting. You don't need to do an overwrite and do a verify. I'm going to do a perform checksum, verify backup, and I want to do compression. Even though this one's not that big, but when you do compression, it's always good. Okay, now it's going to back that up. And we're going to look to see the size of that backup. Here it is. Okay, so here's my size. So my large backup, because when it was compressed, was 11 gigabytes. Right? My large backup is 11 gigabytes. That's the one I told you takes like an hour and a half or 2 hours to restore. But look at my small one, the new one, 524 megabytes. Okay, so it's like I say, it's so much smaller than the large one. Okay, so even on the backup, you can see that. Okay, so let's go back. Database is done. The backup is finished. Okay, that's good. Okay, at this point, I would do a few more things, but it's going to take too long, and I'm going to do them in a different video. And that is the backup I just made of the new smaller database has more housekeeping to do there. I have to restore it back and change the file names, the physical file names, and then change the logical file names, then destroy that backup, and then reback it up under the proper inside file name. So it's all really crisp and really good. Right now it's a little tainted Again, I have to do the housekeeping, and it takes a while, and I don't want to take any more time away from this video that's supposed to be focused more on this database snapshots and the usefulness of it. So I'm going to go back to that in a different database, but there was some steps here that I must skip for that particular part of it, re-emphasizing the snapshot. Now, I'm about to go into step number 8, and step number 8 does a truncate of the rather a restore of the snapshot. Now, the restore of the snapshot is going to be very quick. This is probably most likely due to the way I truncated the large table, the 517 million rows. I truncated it. If I deleted it, I think it would have taken a long time to delete, and also a lot longer to have the snapshot restore. Okay, so just keep that in mind. If you're going to do a delete or something like that, the truncate, if you can do truncate, that's a minimally logged operation, and it's very quick, very powerful, but very quick. And but when I do the truncate, I get a very quick snapshot back on this thing. So I just want to point that out to you, that I did a truncate and not a delete. If I did a delete of 517 million rows, that would have probably taken a very, very, very long time. And possibly the snapshot would also, the restore of the snapshot would have also taken a very, very long time. Okay, with that said, we'll move on. Restore the database snapshot to bring it back to the large state. Okay, so we know our current database is in this 601,000 rows, right? But now I'm going to bring it back, and I'm going to, okay, so if I select it again, which we know the answer, it's 601,000. But then here I'm going to do what we do as a restore from that database I created initially, right? The snapshot. So I'm going to restore the database from that snapshot, okay? Now, and then we're going to see how long that takes, okay? We know if we had to restore it from a normal database, it's like an hour and a half. Okay, so let's go ahead and kick that off. All right, well, that took 16 seconds, which is pretty darn quick. So let's see what happens when we do with rollup here. Now I'm going to test that database again on that big table. Let's see if it all came back. And I go to execute. And if things go right, we'll see 517 million rows there. Okay, well, the query took 2 minutes and 45 seconds or so. And the database came back in what, 16 seconds, right? So that's pretty cool. Let's see, the restore took 15 seconds. Now that is fast, huh? Okay, and the query to figure out whether it was right or not took 2.5 minutes. But you know what? There it is. There's our number. So all the data's back. All that data's back. So that's what I'm trying to show you. Now we did all of that in, with all the chatter of mine, in less than 45 minutes, or actually started at the 25, so probably like 30 minutes or less. Okay, so that's what I'm trying to point out, is that this database snapshot, let's see what else we got here. I'm going to finish up with one more thing, but the database snapshot is so fast. We were able to, we didn't have to go through a full restore. But again, there's a lot of things you need to know about it before you start utilizing it. Okay, it's not a real backup, so don't go wiping out all your data and not have any real backups, because if you lose that snapshot, there's different things with it that you got to be careful. But there's also a lot of other scenarios where it really is fantastic. Okay, we're going to go ahead and do step 9 real quick, and that's to drop the database. Remember, we're dropping the snapshot. Do not drop the real database. You drop the snapshot database because we don't need it anymore. We did the restore, and now we don't need it anymore. So let's go and take a look at it. We over here in database snapshots. There it is. I guess you could probably right click and just delete it from the GUI here. But let's do it through the code here. So I'm just going to drop that. Execute. 8 seconds. So let's go back and see if it's still there. Well, it's there, but let's go ahead and refresh it. And that should be bye-bye. It's bye-bye. Okay, so that's gone. Okay, and let's go to step 10, which we just did. Check in SQL Management Studio, which I checked, and it's not there. So, okay, those are the 10 steps. Again, that 7th step, we have to, we're going to have another video on that, on how to bring back from a backup and change the internal names properly, so you finalize that proof of concept, the new proof of concept database you created there. So that's a little bit of housekeeping. It takes a little time. So yeah, so that's it, the 10 steps. And we're going to conclude the video now. I really hope you enjoyed it. I know it's a little long, and for one subject matter, but that subject matter is so important in the bigger scheme of things. Because you're talking about your whole development system, and when you get things organized right, it can save you so much time in the future, just by being able to pull in this proof of concept or that one and organizing. And some of this database stuff, if you're a developer, it's kind of a database administrator like stuff. But if you're a developer and you know some of this DBA stuff, it can really make your life a lot easier as a developer. So I don't feel bad about the video going on longer, and I'm emphasizing this material because it's good stuff, and it really pays back. And I hope it's not too painful, but I think it's worth it. Otherwise, I wouldn't be doing it. Thanks. Bye. If you like this video, please subscribe to my channel. Also, if you need help solving SQL Server problems, I offer a remote help service for writing code, configuration, and training. You can go to my website shown below for more information. I hope this video has helped you and made your day a little better. Thank you.